Okay, now that we know the tasks involved with designing a beam, we're gonna size the beam and then determine the steel, but I'm gonna show you how to determine the steel first, do step two. Let's go to that. So if you already have sized the beam and you need to now figure out how much steel, this is what we're gonna do. And it's an easy process. Now that you've sized the beam, you can get the self-weight, and then you can do the structural analysis and get the maximum moment. Then you figure out how much strength the beam will need. And then these are the steps to get the AS. We're gonna calculate the RN and then get the rho and then get the area of steel. Then there's a practical part of actually choosing the steel, like what bars and will it fit. And then finally, always check at the very end that phi mn is greater than or equal to mu. Okay, so for example, let's say you had this 20-foot simply supported beam. There's the live load, the dead load, and you now know you have a 1 foot by 2 foot beam. You can calculate the self weight. And so the weight per foot is the area times the unit weight. So the area of the cross section is 12 by 24, but we need it in feet squared. So 1 square foot equals 12 inches squared, which is 144 square inches. So divide by 144 to get square feet. That's a cross section, or in this case, it should come out to 2, right? 1 foot by 2 foot, 2 square feet. And the unit weight of concrete with the steel, reinforced concrete, is about 150 pounds per cubic foot. If you made concrete last semester in our 3210 class, it came out to 145 PCF for the concrete, and with about 1% steel, it bumps up to 150 PSF. And so this is, the units are feet squared, and this is pounds per foot cube. So this comes out to 300 pounds per foot, or 0.3 kips per foot. And so the total dead is the 0.5 applied plus a self weight of 0.8. Okay, and so now that we know that, you can get the live moment. In this case, WL squared over 8. Depends what kind of beam you have. That's why you took structures 1. You can get the moment. I've picked an easy one, WL squared over 8. There's the dead moment, and then you factor it, 1.2 dead, 1.6 live, and we get 128 foot kips, or kip feet for mu. So the beam, the reduced nominal load strength has to hold at least 128 foot kip. So here it is, phi mn is greater than mu. So mn has to be greater than or equal to mu over phi. So the minimum it has to have is that 128 divided by 0.9. So it should be bigger. If you get smaller, you did something wrong. So 142.2 feet kip feet. And we're going to do everything in inches for the cross section. So I multiplied that by 12, and I get 1707 kip inches. Okay, so you know Mn, and we're trying to get area of steel. This is parallel to knowing Rn and calculating rho. And so remember this. So you know Mn, and we're trying to get to the steel. And so we're going around the horn. We're going from Mn, we're going to change it to Rn because we have an equation between Rn and rho. And once we name the rho, we can then get the AS. So you can think of this. This is the this row here. You can think of this row here is the non-dimensional equations or world. And this row here is the dimensional, which is what we live in. Okay, so you know this, you want to get this, but we can't do it directly. So you convert Mn into Rn because we have this equation. And then once you know rho, you can convert it back into the physical units of AS, which is, this is the whole goal. We want to know that. Okay. So here we go. Rn is just mn over bd squared. And so we just calculated this mn. There's b. And remember, d is h minus 2.5. Be careful with your units. That was kip inches, so this is KSI. Okay. And then now you have to use this equation. So remember, I've got this in KSI, so you're going to need FY and KSI. And you plug it into your calculator, so I'm going to skip the details, and you get this, okay? 0.538%. It's between the min and the max, so that's good. And so finally, another way to do it is I've got this equation in my calculator. And so what I did was I just typed, what was it, 0.308. So in my calculator, I can type this in. I can type that in. I type all that in, and my calculator says solve for rho. And it came out to that, the same answer. So you can either just plug and chug with this, or solve this in a calculator. Okay? I just have this in my calculator to do that. Okay, and to make sure it's less than max or min, I can't remember. What was our F prime C? And where is it? Oh, where'd it go? Oh, I don't have it in here. I'm pretty sure it was 4 and 60. So I didn't write it down, but I'm pretty sure it's 4 and 60. I always use 4 and 60. And so I have this table I've made. So if your F prime C is 4 and your grade 60, here are the min and max steel. And so we need to be between 0.33 and 1.79%. And we were at 0.5%. So this is good. You do not need to calculate rho min and rho max because I have these tables for you. Okay. So finally, we have this rho that we calculated and just multiply by B and D. And you get 1.39 square inches. Okay, and then I told you that if you take MU, 128 foot kips, and divide it by 4D in inches, that would give you approximately the AS to double check that that went okay, because you know that involved a lot of calculation. So yeah, that comes out to 1.5. And so we have confidence that that 1.4 is correct. Okay, so now we know that we need 1.39 square inches. You can use tables in a book. You can use my A and B table in Excel. Make sure it fits. And I ended up choosing 2 number 8 bars. It was 1.58, a little too high, but that's fine. You can't go below 1.39. And the minimum width was 7.3, less than the 12 inches. So let me show you how to use that table. Okay, so we needed 1.39 square inches. So what I'm hunting in this table for in the bold is anything greater than 1.39. You can't put 1 bar in. So a minimum of 2 bars. So let me look. So I'm going over 2 bars. I'm looking for 1.39. There it is, 1.58. And it has a minimum width of 8.3 inches, less than 12. Maybe I could use 3 bars and get closer to 1.39. So let's check 3 bars. Oh, 1.32 is too small. 3 number 7 is 1.8. That's more than 2 number 8s. I'm just going to stick with 2 number 8s. That's how I picked it out. Okay. So check the capacity. You should do this. It'll be a good review. So let's check if this is okay. Oh, here it is. Yeah, it was grade 60 bars. F prime C is 4. So is it adequate? So that do T equals Fy AS equals 4. 2 number 8 bars. Oh no, what was it? 1.58. So 60 times 1.58. Okay, so that comes out to 94.8 kips. T equals C, solve for A. So 0.85 F prime C times B times A equals 94.8. A equals, oops, 0.85. 2.32 inches. Oh, I'm going to double check that. I did something weird in my calculator. 0.85, 4, 12. Yep, 2.32 inches. Z equals D minus A over 2. 21.5 minus 2 divided 21.5. 20.3 inches. And MN is T times Z. I'm just going to take that 20.3 and multiply it by 94.8. 1928 inch kips divided by 12. 160.7 foot kips. Phi MN, 0.9 of that. 144.6. Greater than MU, which was 128. And I always like to see what the ratio is. 1.13, 13% over design. It couldn't be helped. That was the closest we could get to steel. Okay, so next we're gonna learn how to size the beam. That will be the next video.